And welcome back. As we continue our conversation around exceptions, today we're going to go ahead and look at the exceptions that we have to the catch or declare rule, which we talked about and introduced in our last lesson. So just as recall, the catch or declare rule has a couple things. All right. First off, in most ordinary cases, an exception must either be caught in a catch block or we declare it through a throws clause. Now, again, this is just what we talked about last time, is what we introduced when we were using this with our methods. But just like with any rule out there, there's always an exception, right? There are some classes whose exceptions you do not need to account for in this way, although you can technically catch them in a catch block if you really want to. These are typically exceptions that result from errors of some sort. They usually indicate that your code should be fixed, not that you necessarily need to add a catch block. So what are those exceptions of the rule? Well, these are often thrown by methods that are from the standard library classes, but of course, remember, it is still legal to throw one of these exceptions in the code that you write. Exceptions that are descendants, for example, of the class runtime exception do not need to be accounted for in a catch block or within a throws clause. Another category of classes called the error classes behave like exception classes in that they can be thrown and caught within a catch block. And just like with the runtime exception, you are not required to account for error objects in a catch block or a throw clause. And we start looking at the hierarchy of how throwable objects work here. All the classes, if we look at this hierarchy that follow the catch or throw rule, they pretty much say that, hey, if these objects are thrown, then they must be caught in a catch block or declared in a throws clause. Now, all the classes shown here in the light blue are exempt from the catch or declare rule. So if we look at the throwable class here, pretty much you can see we have two kind of branches. We have the exceptions and we have errors. All right, and these, of course, are anything that's this blue. These are the checked exceptions, which means, of course, we have to catch or declare. And from the exception, of course, we can have a runtime exception, which, again, these do not need to be accounted for with a catch or throws blocks. And any other kind of exception, they must be caught with a catch or throws blocks. If it's an error of some kind, remember, errors do not need to be accounted for with the catch or throws clause. So this is just a nice hierarchy to kind of remember visually where we're going to be using this. Now, what happens if an exception is never caught? Well, if every method up to and including the main method simply includes a throws clause for a particular class of exceptions, then it may turn out that an exception of the class is thrown but never caught. In such cases, when an exception is thrown but never caught, then for the kinds of programs we've seen up to this point, the program will either end with an error message giving the name of the class, or if you're working with a GUI program, which we haven't done, an exception typically is thrown but it's never caught, then nothing's necessarily going to happen. But if your code does not somehow account for that thrown exception, the user may be left in an unexplained situation. Something could happen that is unexpected with their application. Now, in a well-written program, whether we're using more console-based or more of a visual element, every exception that is thrown should be eventually caught by a catch block in some method. And we've talked about this a little bit before. Now, when we start looking at these exceptions, obviously there's checked exceptions and unchecked exceptions. And what does that mean? Well, exception classes that follow the catch or declare rule are often what are called checked exceptions because it's actually checking to see that they can be caught. Exceptions that are exempt from that rule are often called the unchecked exceptions because you don't have to have that, for example, that catch block or that throws clause. You don't necessarily need to know or worry too much about which exceptions you do not or do not need to declare within a throws clause. If, for example, if you fail to account for an exception that Java requires you to have an account for, the compiler is going to say, hey, I think you're forgetting of something, and then you can either put a catch or have a throws clause in there in order to handle that. Now, with the checked versus unchecked exceptions, additionally, exceptions that are subject to the catch or declare rule are called those unchecked exceptions, as I already mentioned, because the reason for that is the compiler checks to see if they are accounted for with a catch block or throws clause. This includes the class's throwable exception and all descendants of the class exception. If we're not subjected to that, again, these are the unchecked exceptions. Now, what about the error and throwable classes? Well, the error class and all its descendant classes are called error classes because, well, they're not subject to the catch or declare rule. And though they're technically not exceptions, you can safely consider them to be, in effect, an unchecked exception. Strictly speaking, the class throwable is neither an exception nor an error class, but it's seldom used and can be treated as a checked exception if you, for some reason, do implement it. Now, what about the throws clause applied to derived classes? Well, when you override a method definition in a derived class, it should have the same exception class listed in the throws clause that it had in the base class, or it should have a throws clause whose exceptions are a subset of those in the base class throws clause. So you do still have to carry these over. Put another way, when you override a method definition, you cannot add any exceptions to a throws clause, though you can delete some exceptions if you want. You can also replace an exception class by any descendant exception class. If you think about it, this really kind of makes sense because an object of the derived class might be used any place an object of the base class can be used. So an overridden method must fit any code written for an object of that base class.